Okay, students, let us read the statement of question which says a car is accelerated on a leveled road and attains a speed of 4 times its initial speed. The car attains a speed 4 times of its initial speed. In this process, the kinetic energy of the car A does not change. B becomes 4 times of its initial kinetic energy. C becomes 8 times of its initial kinetic energy. D becomes 16 times of its initial kinetic energy. Now, students, we know and we have read multiple times the formula of kinetic energy, which is 1 by 2 mv square. Now, we assume that initial velocity is v1 and the velocity after a rise in the 4 times of initial velocity is v2. So, knowing the formula of kinetic energy, which is 1 by 2 mv square, we can find the kinetic energy of the object with initial velocity and the kinetic energy of the object after attaining the speed, which is 4 times of the initial speed. So, v1 is the initial velocity, v2 is the velocity which is the 4 times of the initial velocity. Kinetic energy of the object is calculated by the formula 1 by 2 mv square. Now we are going to calculate the kinetic energy of the object when it has initial speed of v1. So it becomes 1 by 2 mv1 square. Now kinetic energy 2 k2 is the energy of the object when it attains a speed which is 4 times of the initial speed of object. So 1 by 2 mv2 square is the kinetic energy. Now V2 is 4 equals to 4V1. This is V2 which is equals to 4V1. It becomes 16V1 square. Now Ke2 is 1 by 2 mv square into 16. So Ke1 into 16 is actually equal to 16 Ke2. See 1 by 2 mv1 square is actually Ke1, right? So in place of 1 by 2 mv1 square we have written Ke1. So we can see that the kinetic energy of the object increases 16 times of its initial kinetic energy when its speed increases 4 times. So in this case, option D is correct. The kinetic energy of the object becomes 16 times that of its initial kinetic energy.